Welcome back, developers. In our previous video, we explored the essential concept of object-oriented programming in Dart, and I hope you found it insightful. Now, we are moving on to the final installment of our Dart series, where we'll be delving into asynchronous programming and error handling. We will explore how to use async and await keywords to write asynchronous code. Remember, practice makes perfect, and the best way to get comfortable with coding or programming is to dive in and start coding. While this marks the end of our Dart series, where we will continue exploring more Dart concepts as we move into our Flutter series. So, grab your coffee, fire up your code editor, and let's get started. Asynchronous programming is a way of executing code without blocking the main execution thread. It allows a program to continue running while waiting for an operation to complete, such as reading data from a file or making a network request. In Dart, asynchronous programming is achieved by using async and await keyword. Let's take an example. This is the first example of asynchronous programming. So what I did here, I just created a future void main function and marked this async keyword. Why? Because this async keyword is used to mark the main function as asynchronous. And what I'm doing here, I'm just reading a file asynchronously using this file class from the Dart.io library. And there is a variable lines which await a file.readAsLines method. ReadAsLines method returns a future list of a string. So we use this await keyword to wait for the operation to complete before printing the lines to the console. That's how we use asynchronous programming with the async and await keyword. Second example of asynchronous programming. I imported two libraries, DartConvert and HTTP package. Now, in my main function, which is asynchronous function, I am making an HTTP GET request to this JSON placeholder API which having some data. And I'm making this GET request using the HTTP package. Now, my GET method returns a future response.http. So we use this await keyword to wait for the response to come back. And then in my to-do variable, I am decoding my response.body with using of json.decode method, and then print the title of my first to-do item to the console. If I run this, you can see here is my title. You can also copy this JSON placeholder API to your to here. Now you can see there is a user ID, title, and completed. I think my internet is quite slow, that's why it's running it slowly. But this is how you get data from an API. Third example of asynchronous programming, using the future class to run a function asynchronously. Here, I created a getUserData function, which is a future type of string and having a parameter string user ID. So this getUser function returns a future string that resolves to the user data after a 2 seconds of delay. And I'm using the await keyword in my main function to wait for the future to resolve before printing the user data to the console. And it will print the user data with user ID with a 2 seconds of delay. That's how you use a function class to run a function future class to run a function asynchronously. Overall, asynchronous programming in Dart allows for more efficient use of resources and enables programs to handle long-running operations without blocking the main execution thread. Remember that. Error handling in Dart allows developers to gracefully handle errors and exceptions that may occur during the execution of their code. This helps prevent crashes and improve the reliability and stability of the application. Dart provides several mechanisms for handling errors and exceptions. Now, let's handle the exception using a try-catch block. This is a try block and this is my catch block. I wrap my whole operation in a try-catch block to handle the exception gracefully. Now, in my try block, I am dividing 10 by 0, which will cause an error and printing the result. And in my catch block, I am getting this error from a compiler. Now, the catch block will print the error message, which will be in case like integer division by 0 exception or could not divide by 0 causing error, something like that. Let's run it and see the error message is handled with the try-catch block gracefully. If I remove this try-catch block, you can see the compiler gave me error in a red lines. This is how you handle exceptions using try-catch block. Handling errors using on clause. Before we use try-catch block, now we are using on clause like on's unsupported error, which is the custom error message. So I am using on clause to catch the specific error message that will be thrown. I don't want my compiler error message. I am throwing my own custom error message indicating that the operation is not valid. This is how you print your own custom error message if you don't want any red lines or any compiler error message. This is how you handle exception using on clause. Handling error using finally block. We just learned about try catch block, try and block, now finally block. Try catch finally block. In try block again same 10 divided by 0 which will cause error. We are getting error message in the catch block. So now we are using finally block to ensure that a certain piece of code will always execute regardless of whether an exception was thrown or not. So in that case, if there is exception, it's okay. Got this exception message, but I want this line of code or this block of code to be run. In that case, you will use finally block. Overall, error handling in Dart is an important part of writing reliable and robust code, and it's important for developers to be familiar with the different mechanisms available for handling errors and exceptions. Thank you guys for joining me in this Dart series journey. It's been an incredible experience learning about this fantastic programming language together. I hope you enjoyed this last video on asynchronous programming and error handling in Dart. Keep coding and exploring more exciting concepts of Dart to enhance your development abilities. This marks the end of our Dart series, but don't worry, there is still much more to come in our Flutter series, and I'm excited to dive into that with you and explore the exciting world of mobile app development with Flutter. Once again, thank you for watching, and I hope you found the Dart series helpful. If you did, please don't forget to like, subscribe, and share this video with your fellow developer. Keep practicing, keep coding, and I'll see you in the next series.